Alright, this is ASGNQ304, adding and subtracting rational expressions. It's this one, adding and subtracting rational expressions. Alright, here's the first problem, and I'm going to do a couple of these. Alright, here, so whenever you're adding fractions, adding or subtracting fractions, you need to find a common denominator. So x plus 2 is considered the denominator here, and x minus 9 is the denominator over here. So the common denominator is x plus 2 times x minus 9. So I need that for both denominators. Okay, so here, what changed to go from here to here? A factor of x minus 9 changed. So I have to multiply the numerator by x minus 9. And here, what changed between these two denominators? A factor of x plus 2. So I'm going to multiply the numerator by x plus 2. Is that too small? Alright, is that better? Okay. Yeah, that's better. Alright, so again, the denominator was x plus 2 and x minus 9. The common denominator is a combination of those two, so it's x plus 2 times x minus 9. Alright, so go from this denominator to this denominator, the original denominator to new denominator. There's a new factor of x minus 9, so I have to multiply the numerator by x minus 9. Over here, the denominator changes from x minus 9 to those two, x plus 2 times x minus 9. So the new factor is x plus 2, so I have to multiply the numerator by the new factor of x plus 2. Alright, so that becomes 9x squared minus 81x. And since it's over the same denominator now, I'm going to go ahead and do that. Plus, distribute that, that's going to be 9x plus 18. All we do now is combine like terms. So it's 9x squared minus 72x plus 18. X plus 2 and x minus 9. Okay, I understand that some people may require you to multiply that out. I prefer the factored form, so you can just leave it just like that. Alright, let's go on. Let's do another one. Let's do one that's a little different. Let's do number 4. So here is number 4. Okay, now we haven't been factoring yet, but when I see something like this, there is a common factor. If you can check out a common factor, it's in your best interest. So I'm going to go ahead and factor that out, doing nothing with the second fraction. Alright, so here the 5's cancel. What this has done is made the denominator simpler. Okay, so there's less work involved. Because in the end, that would have made the last part where you have to do something with the numerator and denominator to reduce it. But here, if you reduce in advance, there's less reducing later. Alright, let's continue. So now the common denominator is b minus 4 times b plus 3. It's very convenient when they're unique factors and they're just different. Alright, so b minus 4, b plus 3, b minus 4, b plus 3. Alright, so I'm changing the b minus 4 to this combination. So I have got to do what? I have to multiply the numerator by the new factor. And again, over here, the 6b is the numerator, but I've changed the denominator from b plus 3 to b minus 4 times b plus 3. So I have to multiply the numerator by the new factor of b minus 4. Alright, multiply it out, so it's b plus 3. 1 times b plus 3 is b plus 3. Multiply that out, so it's 6b squared minus 24b over the same denominator. Okay, over the one denominator, rather. Alright, let's clean this up. I like to have the highest exponent first. And minus 24b plus b is minus 23b and plus 3 over that denominator. And final answer. Alright, that's it. Let's see if there's another one worth doing. Oh yeah, number 10 is worth doing. Let's do number 10. Oh, here, I'll do this one. Number 10 is This is 10 plus, oops, can't see that. 10 plus 9 over 3m squared plus 22m plus 35. Yeah, I made the mistake of letting the numbers get too big on this one. Alright. So, here, you can just rewrite it with the one fraction. 3m squared plus 22m plus 35. Alright, when there's no denominator, you can just multiply these two. So that's 30m squared plus 220m plus 350 plus 9. Now this one, since I'm not changing the denominator at all, that 9 doesn't have to change anything. Alright, the only thing I gotta do now is just add those two numbers at the end. So it's 30m squared plus 220m plus 359 over that denominator. Okay, is there anything else? Let's do one more. I'm going to do number 20. Number 20. Okay, here, not much interesting is going on with the first fraction, but there's a common factor in the denominator of the bottom function, right? 2x. In this case, my x is reduced. Alright, so then I have 7 over 3x plus 5 minus 3 over 2. I'm going to go ahead and put it back in. Why did I put it back in? Well, it really didn't do any good having it out there, right? It wasn't reducing with anything in the numerator, so I went ahead and put the 2 back into the x plus 3. Alright, so now the common denominator is 3x plus 5 times 2x minus 3. Or sorry, 2x plus 6. So that's the common denominator. So what changed? From here to here, the 2x plus 6 is a new factor. So you got to put that in the numerator. From here to here, from the second fraction denominator to second fraction denominator, I have a new factor of 3x plus 5. Alright, go ahead and multiply it out. 14x plus 42 minus... okay. My hesitation is, what am I going to do with this minus? I want to attach that to the 3. When I attach that to the 3, that becomes minus 9x and minus 15. So that's going to be 5x plus 27. And that's it. That's the final answer. That's number 20. Well, I hope those were enough examples for you. Goodbye.